today we're going to look more at using the p5.js library within our HTML projects. And I found finally this website, which is the Coding Train website, and it's kind of like this class, except for it's a class entirely dedicated to p5.js in the form of a website. So that is very, very cool. If you want to, after this class, like during your winter break, if you want to learn p5.js or even JavaScript, which is this nature of code tag. Okay, this is the book, but he has a series of videos for that on YouTube as well. You can do that. So you can kind of take your own class to continue what we have begun. And Daniel Schiffman is an amazing, amazing educator, and he's very engaging over the video, like the YouTube format. So I highly recommend continuing with this if you're interested. But for today, we'll just look at integrating this library with our projects and like kind of talk a little bit about the nuts and bolts of how that works, and try to get super clear on that. So yeah, so we will, and also like think about programming programmatic behaviors into our visuals, and save it in a new file. So we're not in DLM examples anymore. We're in our p5.js library example, and I already kind of made a sample called bouncing ball, but this is going to be the bouncing ball in class assignment, or in class example. And I'm going to make it fully inside of an HTML page. So we'll hit save. And there's something, I guess, that's worth noting here, and that is that we're using a JavaScript library that allows us to do all sorts of crazy things, like making bouncing balls jump around on the screen. And JavaScript is its own kind of very different kind of coding paradigm. It's a programming language. It's programmatic versus markup, which is what we've been doing all semester. So we're finally like exploring these two different paradigms of code and like using them side by side. And I got some books for a demo, just so that you can imagine how this is all working. So basically, like this is, you can imagine this book as your markup stack, right? Like it's all neat and bound together, and like it's all the same thing. It's a whole and complete object onto itself, you know. And this is like the HTML and the CSS markup that we're using to make all of our web pages. And then JavaScript is like this whole other thing. It's a completely different, like bound onto itself, complete paradigm that works well, but it's like totally different. We're writing loops. We're using functions and variables. We're writing like a programmatic iterative code. And what we're doing here with our HTML page is basically we're taking this, and then we're just like opening this, and then we're smushing this entire book like inside of this other one in order to make a thing. Like, and this is like obviously not right, even with these objects, like this is not a good way to store information. Like if you wanted to actually read this, you would like go through it, and then all of a sudden like this whole other thing falls out at you, and you read this whole other thing, and then you go back to your original book, and it's all kind of like, it's a little brutal, right? Like it's all shoved in here, but that's like literally what we're doing. We're taking, I'm demonstrating with books, but we're taking a library, a code library, and a code base, and we're just putting it inside of another code base, which is like built on a completely different paradigm, and we're just like, by virtue of smushing them together, they happen to work, because everybody that has put their communal efforts into HTML and markup, and the web has like collectively achieved this feat of magic, which is to like make these two things work together, make so many different things work together. So it's really impressive to me. And yeah, so we're going to go through a simple example and just kind of like look at how that all goes down. So if we start our HTML page in the usual way with open and closed brackets, then we'd have our head, our body. So we have our sections of the page. And one thing that we need to do is we'll need to reference. So in the same way that we've been doing our link, rel, like CSS, I always forget the next parts, but to bring in a CSS page that we write ourselves, we need to reference the entirety of the p5.js library to do it. We need to call it in. And the way I should have prepared this, I guess, but let's see. I was looking at. So this is on the p5.js website as well, this line, but I took it out of a sample code that I was looking at. And this is just the way that we will reference a JavaScript library. And you see it's very similar to the way we've been pulling in our own CSS pages. But in this case, we are just putting that inside of a script tag instead of putting it inside of a link tag. And this you can put into the head tag. That's a good place for, this is usually where we would reference our CSS pages. So let me look that up again, as I always do. Someday I'll remember it. So if we had a style sheet for this, and we can even create the style sheet, we would put that in the head tag as well. So that's a fine place to keep those things. So it was styles.css. And I can say body. So I'll just give it a background color. One thing that's happening to me in Atom, and it might be happening to you as well, every time I call the script tag, like everything goes gray. That is quite annoying. And what I've been doing is I just write this in. Now everything is gray, so I'm closing the document, and then I'm just going to, that's my Christmas tree. And now I'm just going to reopen it, and the colors are back to normal, which is helpful for me. I'll leave it at that for myself. It may not be behaving that way for you, but that's one workaround I found. This is not a great solution to anything, but Atom is it's a mildly buggy sometimes, so this is a bug workaround. Okay, so we've put our script tag at the bottom of the body tag, and that's a good place to be able to find it. You could put your script tag anywhere you want, but depending on the complexity of your web page, it's just a good standard to keep it there so you know where it will be. So I can say this is awesome interactive. I guess this would be called, so JavaScript, these little JavaScript canvas interactive things that we make are called applets. So I can say this is my awesome bouncing ball applet. So let's look inside of how we structure our code inside of the script tags. So you can imagine also that this is just another way. It's another way of like that we've opened a different document inside of our document. So if you remember the way we would have the style tag in the head tag, and then we would write normal CSS in it. So if I wrote, if I put this inside, let me make it a little bigger for you. If I put this inside of a paragraph, for example, then in the style tag, I could write this, right? And I write it in the same exact way as I write it in a CSS document. So this is the same thing. The same paradigm applies here. Anything that we keep inside of our script tag may as well be in another document that has .js at the end of it, just like this one right here, a separate JavaScript document. But we're just writing it in this HTML page inside of the script tag, and that's the part of this process that makes it be like this. So if we were so inclined, we could even say that the CSS is also kind of like that. So if we have, you know, I'm out of books around me, but like if my phone is the CSS, you know, this is kind of what our HTML page looks like. Like we start with some HTML, then we have like a whole bunch of CSS, then there's some more HTML, then there's some JavaScript, and so on. Okay. Okay, so let's look at some parts for this. So we can start, I want to make a bouncing ball because it's something programmatic and iterative, and it will give us a chance to explore the use of functions a little bit more. So, and do some math. So let's look at that. And we'll start with a variable. We can call it X. So this is kind of like, you know, I suppose a continuation from our math class in high school, in algebra class, where we always use X as the default variable. So there it is again. And we'll set it to 0. Decide to move on outside of the web, and you decide to get into just Java on its own. There's kind of a language built on Java called processing that you can run on your desktop and like start making applets that are more like closer to the apps on your computer rather than web pages. And then that would be in Java. why did I get started on this? Oh yes, because they have the same structure. There's these two loops that come baked into it, and there's the loop that goes once, which is the setup loop, and then there's the loop that is constantly going. So, and we call these loops functions. So, function setup. And function draw. So draw is always happening, and setup happens once. So we could test this by saying we can make a y variable, set it to 0, and we could say and JavaScript works in a stacking like structure, which means that things listed above affect the things that are below them. So this fill 0 is going to fill the shape that I'm going to, or all the shapes that I list below it. So I'm going to list this shape as an ellipse. Maybe ellipse has one L. I don't know. Okay, it has two L's because it turned blue. Great. So I'm going to draw an ellipse once. And since we have x equals 0 and y equals 0 there, I can say x, y. So that's going to be the location. So I'm plotting the points at which I'm drawing the ellipse. And then I'm going to say I want it to be 20 by 20 pixels wide. And I do believe we need a canvas to draw this on. So even though I have this, if I drag it into Firefox now, oh, it's there. I'm surprised. I would have thought that it wouldn't be there, and that we would need create canvas. Yeah. So create canvas is the function that creates our canvas, and I've always set it up, and it never once occurred to me that this would work without it, although I do see our ellipse over here in the corner. Let's just play around with the differences of having it versus not having it. Let's see what this means. Okay, so I've redrawn it. For all intents and purposes, it looks the same. I'm just going to make the background of the canvas be red. Okay, so that's the canvas. So if I remove it, but I keep the background, what happens? Interesting. Okay, so it looks like p5.js, and this is like the part of dealing with libraries where we don't always know all the things that are happening inside of them. It kind of looks like, by default, it gives us a 200 by 200 pixel canvas to draw our things on. That's very interesting. All right, well, so we'll make our 600 by 600 canvas, and we have our ellipse, our tiny little ellipse over here. And so you see that the value of x and y has transferred to the ellipse x and y coordinates over here. So if we set x and y to 300, oh sorry, yeah, to 300, and I reload, So now it has drawn itself on this at the center of that grid, at that intersection. So that's the passing of information through variables. So this isn't a special location. Like I could also put X and Y here. And that would just pass that information to those slots. And since those slots, the two last slots in the ellipse, the two last attributes determine the width and height of the shape, X and Y just passed into the width and height of the shape. Does that make sense? So it's just a means of passing numbers around. We could even say in this create canvas, we could pass the X to that. And now it's 300 pixels wide by 600 pixels tall. So it's a useful way if you're writing code, instead of writing 300 over and over and over again, you can just say X. So you're shortening your amount of input, data input that you're doing. And it's also convenient if, for example, you build a system where everything has, like, let's say it's a design document, you have a layout where everything is proportional to each other in a certain way. And you have a client and they're like, oh, actually, I want everything to be twice as big. I got a new device, and like I'm coding for new devices and they're twice as big. You don't have to go in there and like change every single thing that you've written down. All you have to do is say, oh, okay, if this needs to be twice as big, I'll just change the value that's set to X. I don't need to change all my code. And like, behold, the relationships of everything have expanded to be twice as big. By 200, I'm going to make the ellipse be a normal size again. Okay, so we have our ellipse in there. And when we reload this, it just draws itself once. So what does it mean to draw over and over and over again? So let's take this information and put it in. So we could take all of this and we could put it into the draw loop as well. And for practical purposes, I just reloaded. It looks exactly the same. Nothing has changed. But what's actually happening is that every frame, so our computers, like movies that we watch that have a frame rate, our computers have a frame rate at which they display information. And every frame, it's actually redrawing the background, the red background, and the ball, which we can't see because this isn't dynamic. But if, for example, we changed this to the built-in variables of mouse X and mouse Y, and we remove the background from the draw loop. So we draw the background just once in setup over here, and then we draw the ellipse wherever the mouse happens to be. So now every time I move my mouse, I get an ellipse wherever that mouse is, and I'm like slowly creating all of these ellipses on the screen. I'm like covering the applet with ellipses. With my mouse. But what's actually happening is what we saw before. We're drawing all of those ellipses like all over the canvas, and they're staying there. And then we're drawing the background slab on top of that. Does that make sense? So we have our little stack. The background is like wiping away the ellipse because the ellipse is on top of it. If we drew the background on top, well, I'm not sure this would work in this case because background has a special word. Oh, no, it worked. Because it had that special word background, I was like, oh, maybe they coded into it that it would always stay at the bottom no matter where I put it. But you can see now I put it on top of the ball and we don't see the ball anymore. So that's the render order, a little bit about the render order and a little bit about the looping and about the running once of the setup loop. So let's make our bouncing ball. And I must refer myself to my notes. Okay, so in order to make our ball bounce, we will have to introduce a variable for movement. So we have this x variable right here that we used previously to draw the ball. So let's put it back into that. And we can set it back to 300. So it starts in the middle. And we're drawing our ball at 300 pixels by 300 pixels. So another name that we could give this variable is location. Location of x. Oh, oh, oh. Why did I say reload? So I'm looking at the address and it's maybe it really doesn't like the word location. Is it a keyword? Okay, apparently location is a keyword to something, to HTML maybe, to Firefox. I have no idea. That was wild. So you all saw in the address bar right here, even though my file is called bouncing ball class, like it's replaced by 300 in the address bar. That's fascinating. Okay, so we have our location variable, and that allows us to draw the ellipse. So now we need to add a movement variable. So it needs to move by some amount somehow, and that can be this y that we've created. I'll call it mvmt for movement. And we don't want it to move a lot, or maybe we do, but we'll start with it not moving too much. And so I'm going to set movement to 1 to see just like what one step of movement is. And now the way that I'm going to make it move is I'm going to create a condition. So I'm going to say if, I'm going to say to the computer, hypothetically, computer, if the location of my ball is greater than width, and width is a variable that p5.js gives us, and it refers to the width of the canvas. This right here. So if the location is greater than width, hypothetically, then make your movement, yes, then set the movement to -1. So what I'm saying is, if you've gotten out of bounds, if you are at trying to go to 601 pixels, then start going backwards. That's what this negative sign means. And then I'm going to say, outside of that, that's the bounce part that I've just programmed in there. Location equals location plus movement. So then I'm saying every time you draw the entire applet, redraw this location variable to be plus whatever the movement is. And in fact, I feel like maybe I could have done this later. Just look at the location part for now. And it's off. So this is the speed of my Firefox, and it's gone now. And that was the speed of the ball getting location added to it every time it redraws the frame. But now it goes off the frame and we have no more ball, right? So that's the part where I said, okay, that's great. I'm really happy that you're moving, but if you're and it went back. Amazing. So what's going to happen now is that it goes off the other end. So we have a problem of the opposite thing happening now. So we could say, okay, if the location is greater than the width of my applet, go backwards. But if the location is less than 0, because that was the 0, 0 corner that we were in. If it's less than 0, then set the movement to make the movement variable be positive. So make it go in the opposite direction. It disappeared. No. Is it because a positive of a negative is still a negative? Okay, and since we're troubleshooting, this is the beauty of having variables. I'm like, okay, we're troubleshooting, so I want to see my results quickly. So I'm just going to change that movement variable to 10 so that it goes faster. There we go. Now it's back. But it doesn't like this. Interesting. I wonder if it's like, because what I'm saying is do this and it cancels itself out. Maybe that's why. Okay. Very well. So let's do -10 for consistency's sake. like the applet will start glitching and you'll start getting like glitchy renderings of the ball, which is pretty funny. Also, you can test these in different browsers. So if I open Chrome, I don't know if you see a difference. I don't see much of a difference in this case, but if we start adding colors, if we start making different balls bounce against each other, we might see a visual difference. It does, JavaScript does drain your battery. You can crash your browser with it, like it will crash your browser. So I'm closing Chrome, so I'm not running too many applets all at once. And we can keep going. Okay, so that was our if statement. We can even, I think, set this after. If we draw it after, it should do the same thing. So maybe that makes a little bit more sense. So we're drawing an ellipse at an initial location, and then we're saying every time you move by 10 pixels by this much. But if your location becomes greater than the width, change that setting to backwards, -10. Start subtracting every time you move. And if you become less than 0, start adding again. I'll move on to for loops then, I guess. So for loops are another very important, and I'm gonna actually close this because my computer is overheating. It's not a new computer, so maybe that's why, but okay, so so we've covered if statements. Another thing that we can look at is for loops. And so maybe we could do something about the background in an interesting way with a for loop here. So I'm gonna check my notes. Okay, so a for loop has a very similar statement, very similar structure to an if statement. We have the word for, then we have our parentheses in which we put the conditions of the for loop, and then we have our curly braces in which we put the action that happens if those conditions are happening. So you can kind of see that all of these things have the same structure, and that's because the if statement is also a function in JavaScript. It's like a core function that was defined at the very beginning of like when JavaScript was invented. So it appears, it's color-coded differently, it behaves a little bit differently, but at its like most basic, it's a function, like everything else. This is a function, this is a function, this is a function, and you can recognize them by their syntax. So it has the same syntax, it just behaves in a very specific way. And that way is the way of an if statement, and this is the way of a for loop. Okay, so we can use another variable here. I'm just going to make a variable I. So I'm saying, hey, computer, in the situation in which a variable exists that's called I, so like just in the case that that happens, and if that I variable is set to 0, it starts out at 0, but I'm going to make a condition where I'm also going to add a condition where I is less than or equals to width. So this is also true. So I'm kind of like building a little theorem for the computer. I'm like, hey, in the situation of this theorem existing, we're going to do some things. So I'll say that I exists, it's set to 0. I is less than the width of our applet, which we've already played with a little bit here. And I'm going to say I is going to grow by 50. So I'm saying, hey, I exists. I is in the situation that it's less than the total width of our applet, and in the situation where it grows by 50 every time we loop through, I want you to do some things. And what I want you to do is draw an ellipse, because that's what we've been doing, and draw it at position I, and 60, and make it be 20 by 20 pixels in width and height. So let's see what that gives us. All right, so it just drew a bunch of ellipses. You can see back here. And why did it draw them in a line like that?
Because it's positioned at like y equals 60 for the horizontal.
Right, exactly. We are incrementing from 0 to the width of our applet, which is 600 pixels, on one, and applying that to one dimension, which is the x position of the ellipse that we're drawing. Perfect. So we've created a for loop where we're iterating our ellipses over this horizontal and vertical grid. So the next thing that we can do is we can nest our for loops. And like this, for me, the first time I saw this, I was just like, what? I just didn't understand it. So hopefully I'll do a better job of explaining it to you than my professor did it for me the first time. Okay, so what you can do is you can put one for loop into another for loop. And so if I make this very similar j variable, so I'm saying, hey computer, like, here's a theory, I exist, it's less than the width, and every time you draw, as long as it's less than the width, every time you draw, it adds 50 to itself. And also, as long as that's happening, j exists. And j is, we could say, less than the height. So it's less than the total height of our applet. And we can add 50 pixels every time we run the for loop to j as well. So it looks kind of funny because we have this inside of this. We could reverse them and the outcome would still look the same. But if this for some reason wasn't true, then this would never have a chance to be evaluated. So that's kind of the paradigm this sets up. Is like, this statement is now dependent on this statement functioning because it's inside of that statement. And we can't take it out because if we want to draw this ellipse based on those two statements, it has to be inside both of them, right? So like we can't do we can't really do this. I mean, we could, but it's only going to give us one line, right? So this just gave us one iteration of each one of those because they're outside of each other. But if we put one within the other, then it's going to run every time we run the I for loop. We'll also run the J for loop. So if we put those together, everything disappears. Because I'm missing a curly Q, maybe. Let's try that again. There we go. So if we put those together, we're now, every time we run one line, we run another line, and then we move over 50 pixels, and we run the next line and the next line. And then just the same way the ball is moving up and down like this, the for loops are moving up and down. But because they're static, because they're not going anywhere, we have them just, it appears as though it's like a fixed grid, but it's actually redrawing them every time. If there was a good way to, ooh, maybe we could like, maybe this will work. Let's see. No, it didn't like that.
So you can see when I move my mouse around, the balls are redrawing at the location of my mouse. And because we are redrawing the background with every frame, it appears as if they're just following my mouse. But in actuality, I'm drawing a whole new grid.
Now you can see it first ran once in the background, so we have that. My internet connection is unstable. So we have that that grid in the background, and now it's following my mouse, and we can very quickly just like cover this entire image with ellipses. And I have to close some of these documents. And what I can do is I can comment this out a little bit so that we can, and then I can send it to you so you can review it. I think that's the best thing to do. Okay. So we have our CSS linking over here. That's all stuff we're used to. We have a little declaration of what's going on, and we can always add more and more information around this. So we have this like applet that we created on our webpage, but we could design a whole webpage around it. Like we could use the grid, CSS grid functionality and like make it be one of the blocks on our grid, for example. And here we can describe what's going on. So we're declaring variables that we will need to on the ball, and then function setup, the special function that runs once, in which I am specifying a canvas of size 600 by 600. So that's all I need to do here in this case. But maybe, you know, if I had a different design, I would have to do more. And then here we have our function that runs every frame the browser renders. That doesn't quite make sense. So like, how can we put this? So everything on our computers runs at a certain frame rate. The frame rate is determined by CPU cycles. That's our processor in the computer. Or it can be determined by GPU cycles. This is why people talk about programming on the GPU and that the GPU is faster than the CPU. And so that's why we do this. That's why we program on the GPU, because it gives us a faster processing ability than CPUs have. So GPUs were designed to make our screens function, to render graphics, and they were designed very, very well because they were made for games to render quickly. They were made for visuals to render quickly, for like VFX artists working on film. Like those are the consumers of beefy GPUs, right? So at some point, the ability of the graphics processing units to run cycles became faster than the ability of the computer processing unit to run cycles. So that's why we program on the GPU. But basically, like these are the two things that determine our frame rate, and they talk to each other because anything that the CPU thinks through and like any code that it runs, not all of it, but most of it still has to be rendered to the screen so that we as humans can perceive it. If we don't see it on the screen, like it doesn't matter that the computer's doing it, right? Although it does do many things that it doesn't render to the screen, like network processes, you know, hidden processes of all sorts. We don't see rendered to the screen. So those are basically the two engines that determine the speed at which things run. And within that, different applications have their own frame rate too, right? So like Firefox runs at a certain frame rate, and that might be different from Chrome. Sometimes Chrome is doing more things in the background that slows it down. Like sometimes Firefox is not up to date on the latest whatever on the internet, so that slows it down. So they'll have just like slightly different behavioral speeds that have to do not just with how the application was programmed, but also what hardware it's running on. So what speed is your CPU on your computer? How current is your OS? Like what rate are all these things talking to each other at? It's a crazy, crazy ecosystem out there. It's amazing it works at all, really. So our function, which is all to say that our function runs every frame the browser renders, sure, if that makes sense. And there's also even we can force render. So some applications will allow you to force a rendering rate. For example, like if you're doing visuals in something like Max MSP or Pure Data, you can force the CPU, which means that you say, hey CPU, like no matter what you think you should do, I want you to render this graphics app that I made 60 frames a second, no matter what. And it will do that, but that will cause it to start dropping other processes, for example, because it can't do all the things. So it's going to start like dropping other things. Or maybe that'll cause it to physically start overheating because it mechanically just can't run that many cycles. And then your computer might like melt down and go to sleep because it overheated. So that's also something that you can do. Most applications don't let you do that for obvious reasons. We don't want to melt down our computers, possibly damaging them for a long time. But like, even that is accessible. Like we can force these things if we absolutely have to for some reason. I've definitely done it before. There's calculated reasons. Like you could say, okay, I'll turn everything else off, and if it goes to sleep, that's the end of the show or whatever. So long story short, frame rates, they exist everywhere. Okay, so and within this drawing cycle, we're setting our background to red. And filling everything drawn after that in black. So we could also, just for the sake of like demonstration, if we have a purple ellipse and we'll just draw it at, I don't know, we'll just draw it at 100 pixels in. I'll make it kind of bigger so we can see it. Oh, that's funny. Okay, so there's my larger ellipse that I just told it to draw over here at 100 by 100. It also changed the fill of all of our for loops, right? Because we're saying fill 0, draw the ellipse that's bouncing, and then we're saying fill 255, and then all this other stuff is under it, right? So as this loop is running, it's not going to change the color until it encounters the next fill. So you can imagine it being in a circle, you know, going in the loop. And so the color of our ellipses here also received that purple color. And you can see now, because of the coloring, that they're actually being drawn on top of the bouncing ellipse. I wonder if we
pass J to the R of the RGB value, will it change the color of our fill in an incremental way?
we can even give it, we can map that information on the horizontal and on the vertical line. And so then if we made this be closer, and if we made this a little smaller, then I have a gradient. So it's a way of making a gradient. And if I say no stroke, I'm getting carried away now. I'll stop. Okay, so if I said no strokes, so now I've made a gradient happen on my square. And just one last thing, if I take this this ellipse, the bouncing ball, and I put it after these ellipses that I just drew, so I've changed the order of my stack, then it's again bouncing on top of the ball. I'm going to take this away because it's annoying me. So now it's again bouncing on top of our grid of ellipses that we just drew. Now this is a very expensive way of drawing a background. That's why actually I made my window smaller, because if I made this be 600 by 600 again, so even the paltry size of 600 by 600 pixels, you'll see my computer slowing down. Like you can even see this black ball is like going up and down much slower than it was before. And that's because I'm asking the computer to do a lot of work. It's drawing a lot of circles, and it's drawing them every time, and it's not erasing them. They're just stacking up. So at some point, it's just gonna get even more unhappy. Now, I don't think I can crash Firefox with such a simple app as this, but I can get pretty close, probably. So that's something to think about, I guess. As you work. And on that note, I'm gonna close this while I comment my. So when I close it, it stops running the process and it frees up memory again. Okay, so here we have set this to make this small again. And then we can say for loop iterating through the values of I on the horizontal. And this is a for loop iterating through the values of j on the vertical plane. And we could change this. So these are just numbers. This width and height corresponds to this 255 by 255. So I could say this here as well, and it'll give me the same result. Same thing. And if, for example, if I set this to 50 instead, so I'm shrinking it, now you see the ellipses are just doing that little part at the top. If I switch these two variables of where the ellipses are, or of where they're drawing rather, it should give me a vertical plane. So it's not that this I and j here are fixed to the vertical, that it's not that the I is inherently horizontal and that the j is inherently vertical. It's not that. The j is just going up to 50 and the I is going up to 255, which is why we see over here the full length of our applet being covered by ellipses versus just a small amount. The thing that makes it appear horizontal and vertical is that I'm passing that information into the horizontal, into the x, and into the y anchor points of the ellipse. So it's just running out of j's here. It runs out of j's very quickly, but it has a lot of i's to keep going. So it can keep trying the y's, but it runs out of j's. So yeah. So maybe we can even say of j through to 50, and this and then filling the ellipses with the values of I, j, and 0. And drawing them at those values as well. So we're filling them with those variables and we're drawing them at those variables. Okay. And then here, I'll just annotate this real quick. So that's that loop, that's the background loop, and then here we have the loop that's sitting on top of it, and we're drawing an ellipse at at the x and y coordinates of variable location. So we're drawing it at the coordinates of what we set location to. And then we're iterating location by the value of movement every frame the app runs. And then, last thing, but if the location becomes greater than the width of, oh man, my fan is going off again, okay, becomes greater than the width of our applet, set movement to -10, and if it's smaller than the width, well, not the width, than the start point of our applet, draw with positive numerals again. Okay, so that's our program that we wrote in JavaScript using loops, variables, functions, if statements, and we've smushed that whole thing into an HTML page, and it works awesomely. And that is because we added this script tag over here, which references all of these, like all the places where the setup function is defined, the draw function is defined, fill, all of that is defined in this document. And we can actually go and look at this document. If it's there online, here it is. And you can see this is like code that we're used to now. It makes sense to us, kind of. We recognize like if maybe call a.exports kind of makes sense, right? So this is where we're defining all of these things. This is JavaScript defining p5.js. And if we didn't have this, you will see that everything will break. So we still have our CSS, that still works, the page is still purple. I have my paragraph that I wrote, but the applet is gone because we are not pulling in the library anymore. So that's the importance of that. Okay, and we are past our class time, but I will send this to you and the recording, of course.